about the word Earth, we automatically think of this planet right here that we all live in. But what exactly makes Earth so special? Let's find out through geology.
Sunod kayo sa akin. Ate, what do you think is the meaning of geology?
Study of Earth, yata.
Exactly.
Geology came from the Greek word ge or geo, which means earth, and logia or ology, which means study. Geology is the study of the earth, the materials of which it is made, the structure of those materials, and the process acting upon it. Geology in civil engineering. Geology has a vital role in three main aspects of civil engineering, such as in planning, designing, and constructing. First, in planning. Geology provides information which are useful in planning a project. It allows the civil engineers to have an ability to read and interpret information from geological, hydrological, and topographic maps and photography. Next, in designing. Civil engineers have the consideration regarding the geological characteristics and phenomena before designing, such as the mechanical properties along and across the site of the proposed project, existence of rock formations and occurrences, position of the groundwater table and totality, seismic characteristic of the area, its history and prediction of future seismicity, presence, nature, and distribution pattern of planes of the structure, weakness, and hazard. Lastly, in constructing, engineers are responsible for the quality control of the construction, wherein they are beneficial to geological background of nature material such as sand, gravel, and other rock formation. Similarly, in harnessing the knowledge of geological history and data of an area. Geology allows to provide a safer and lesser hazardous composition of an infrastructure.
What are the branches of geology?
Physical geology or geophysics, concerned with the physical processes and physical properties of the Earth and its surrounding space environment and the use of quantitative methods for their analysis. Petrology studies the origin, composition, distribution, and structure of rocks. Mineralogy, the study of minerals, its composition and properties. Structural geology, the study of the three-dimensional distribution of rock units with respect to their deformational histories. Stratigraphy studies rock layers and layering. It is primarily used in the study of sedimentary and layered volcanic rocks.
Paleontology is simply the study of ancient life, the study of fossils to determine organisms' evolution and interactions with each other and their environments. Crystallography is the experimental science of determining the arrangements of atoms in the crystalline solids. Mining geology is an applied science which combines the principles of economic geology and mining engineering to the development of a defined mineral resource. Geology engineering, or geotechnics, is the application of scientific methods and engineering principles to the acquisition, interpretation, and the use of knowledge of materials of the Earth's crust and Earth materials for the solution of engineering problems and the design of engineering works. Hydrology is the study of movement, distribution, and quality of water of Earth and other planets, including the hydrologic cycle, water resources, and environmental watershed sustainability.
And now for the works of geology by wind, groundwater, river, and sea.
Geological works by wind. Wind erosion. Wind performs the work of erosion by at least three different methods. First is the deflation. Wind possesses not much erosive power over rocks, but when moving with sufficient velocity over dry and loose sand, it can remove or sweep away huge quantity of the loose material from the surface. This process of removal of particles of dust and sand by strong wind is called deflation. Second, wind abrasion. Wind becomes a powerful agent for rubbing and abrading the rock surface when naturally loaded with sand and dust particles. This type of erosion involving rubbing, grinding, polishing the rock surface by any natural agent is termed as abrasion. Lastly is the attrition by wind. the sand particles and other particles lifted by the wind from different places are carried away to considerable distance. The wear and tear of load particles suffered by them due to mutual impacts during the transportation process is termed as attrition. Geological works by river. Method of river erosion. Streams and rivers are the most powerful subaerial agents of erosion. Others are ice, oceans, etc. Features of river and stream erosion. First is potholes. These are barrel-shaped depressions of different dimensions that are developed in the riverbed by excessive localized erosion by the streams. The potholes are generally cylindrical or bowl-shaped. Next is valley. A valley may be defined as lowland surrounded on sides by inclined hill slopes and mountain developed by process of river erosion. Next is gorges and canyons. The process of valley deepening often gives rise to magnificent surface features known as gorges and canyons. Gorges are very deep and narrow valley with very steep and high wall on either side. Next is the waterfall. These are defined as magnificent jumps made by stream or river water at certain specific parts of their course, where there is sudden and considerable drop. Falls are attributed to unequal erosion. Next is stream terraces. These are bench-like ledge or flat surfaces that occur on the side of many river valley. From a distance, they may appear as succession of several steps of a big natural staircase rising up the riverbed. Next is the river meandering. When a stream flows along a curved, zigzag path acquiring a loop shape of course, it is said to be meander. Oxbow Lake. U-shaped lake that forms when a wide meander of a river is cut off, creating a freestanding body of water. It is an advanced stage of meandering. Estuary. Partially enclosed coastal body of brackish water with one or more rivers or streams flowing into it, and with a free connection to the open sea. Lastly are the rapids. Rapids are sections of a river where the riverbed has a relatively steep gradient causing an increase in water velocity and turbulence. Geological work of oceans. There are many geological work of oceans. One of it is marine erosion. Marine water erodes the rock at the shore and elsewhere with which it comes in contact in a manner broadly similar to that of stream water. The work of erosion is accomplished in three ways: hydraulic action, abrasion, and corrosion. First, hydraulic action. This is the process of erosion by water involving breaking, loosening, and plucking out of loose disjointed blocks of rocks from the original places by the strong forces created by the impact of sea waves and currents. Next is the marine abrasion. This involves the rubbing and grinding action of seawater on the rocks of the shore with the help of sand particles and other small fragments that are hurled up against these rocks. Lastly is the corrosion. It is the solvent action of seawater which is particularly strong in an environment where the shore is of vulnerable chemical composition. Also, headland and bays, another geological work of ocean. Bays are usually formed where weaker rocks like clay and sand are eroded, leaving a band of harder rocks. Bays and headlands are formed where the parallel bands of harder and softer rocks are perpendicular to the coastline. Another geological work is sea cliffs. A sea cliff is seaward facing steep front of a moderately high shoreline and indicates the first stage of the work of waves on the shore rocks. Next is the wave-cut terraces. Wave-cut terraces is a shallow shelf-type structure carved out from the shore rock by the advancing sea waves. Now, let's move on to the depositional features of the sea. The principal depositional features are as follows. First are the beaches. These are loosest deposits made by the sea near the shore from the materials eroded from nearby regions. The lower margin of a beach is commonly beneath the waves, whereas the upper margin is a few meters above the still water. Next, splits and bars. These are ridge-shaped deposits of sand and shingle that often extends across the embayment. Next is tombola. It is the form of marine deposit that connects a headland and an island or one island with another island. Geological works of groundwater. Groundwater, like surface water, is also a very powerful natural agent responsible not only for modifying the existing features but also for creating many other geological features on and below the surface of the earth. The following are a number of forms that are developed due to solvent action of water. First are dolines. These are also termed as swallow holes, sinkholes, and sometimes simply as sinks. A typical doline is circular or oval depression. Next are caves. These may be defined as naturally carved out underground cavities of various dimensions that will always have horizontal opening on the surface. Lastly are the blind valley. Blind valley is a valley-like feature where a stream flowing through it in the upper reaches suddenly disappears in the lower reaches. Groundwater is the water which occurs in subsurface rocks. The knowledge about its quantity and depth of occurrence is required in connection with water supply, irrigation, excavation, and many other civil engineering works. Enough of what geology is, let's go back to Earth 101. But before we go deeper into the topic, let's first tackle about the structure of the Earth.
The structure and composition of the Earth. A little history about the Earth. The natural resources of our planet were discovered since the time of Christopher Columbus' first voyage, but the internal layers of the Earth were revealed not until the Cold War era. The Earth is composed of several zones, including a central core, a mantle, and a crust. Crust. Earth's outer surface is its crust, a cold, thin, brittle outer shell made of rock. The crust is a comparatively thin outer skin that ranges from 3 kilometers at the oceanic ridges to 70 kilometers in some mountain belts. There are two classifications of crust, each with its own distinct physical and chemical properties, the oceanic and the continental crust. Oceanic crust is composed of magma that erupts on the seafloor to create basalt lava flows or cools deeper down to create the intrusive igneous rock gabbro. Continental crust is made up of many different types of igneous, metamorphic, and sedimentary rocks. The average composition is granite, which is much less than the mafic igneous rocks of the oceanic crust. Mantle. The mantle is the inner layer just between the crust and the outer core of the Earth. The two most important things about the mantle are 1. It is made of solid rock, and 2. It is hot. Core. The core is the innermost part of the Earth, which is believed to be a magnetic iron-nickel-rich sphere that is consisted of a 758-mile thick solid and a very dense inner core that is overlain by a 1,400-mile thick zone of dense molten material in the outer core. There are two classifications of core. 1. The outer core. The outer core of the Earth is a liquid layer of iron and nickel 2890 kilometers beneath the surface of the Earth. The constant churning of liquid iron of the outer core creates magnetic fields and electricity. This continuous process is called the geodynamo. Next is the inner core. The inner core is a solid ball composed of iron and nickel along with some light elements like oxygen and sulfur. It is a widely held belief that the inner core is gradually expanding as the liquid outer core cools down and solidifies where the two layers meet. This growth is believed to be important in generating the planet's magnetic field.
Teka, ano nga ba ang plate tectonics yun? Ganito kasi yan. Plate tectonics is the theory that Earth's outer shell is divided into several plates that glides over the mantle, the rocky inner layer above the core. The plates act like a hard and rigid shell compared to Earth's mantle. This strong outer layer is called the lithosphere, which is 100 kilometers thick according to Encyclopedia Britannica. The lithosphere includes the crust and outer part of the mantle. Below the lithosphere is the asthenosphere, which is malleable or partially malleable, allowing the lithosphere to move around. How it moves around is an evolving idea. The driving force behind the plate tectonics is the convection in the mantle. Hot material near the Earth's core rises and colder mantle rock sinks. The convection drive plate tectonics through a combination of pushing and spreading apart at mid-ocean ridges and pulling and sinking downward at subduction zones. Scientists continue to study and debate the mechanisms that moves the plates.
According to plate tectonics theory, these massive lithospheric plates were all moving in different directions, and how they interact with one another can have a huge impact on the Earth. Where these plates meet are called boundaries. There are three types of plate tectonic boundaries. Convergent occur when two plates are moving towards one another, transform occur when two plates are sliding past one another, and divergent boundaries occur when two plates are moving away from one another. Now let's take a look on how they actually work. When two plates collide, a lot of things can happen. Usually, the heavier and denser plate will dive under the other. This creates what is called a subduction zone. And the deeper under the Earth's surface that plate goes, the more pressure it creates. That pressure coupled with the high heat causes the formation of magma and, you know what's next, a volcano eruption. The other possibility is the land above the boundaries will be lifted up and form mountains. Example for that is the Himalayas. And because the plate tectonics continue to move, the peak of Himalayas also continues to grow. At transform boundaries, the two plates slide from different directions, which create a fault line on the Earth's crust. As the plates move, they rub against one another, and the pressure will build up. This pressure will trigger an earthquake. An example for this is the famous San Andreas Fault located in California. That leaves us with divergent boundaries, which occur when two plates move away from one another. This will result to a crack or a rift. When this happens underwater, where the crust is thinner, magma oozes up from the Earth's mantle and fills up the space. This is called seafloor spreading. An example for this is the Mid-Atlantic Ridge, which created the longest chains of mountains in the world due to seafloor spreading.
1 minute, see you tomorrow.
Uy, teka! Oops! Huwag na kayong makisawsaw dyan. Let's move on to continental drift theory. Ano nga ba yung Chami?
Ganito yan.
Continental drift was a theory that explained how continents shift position on Earth's surface. Set forth in 1912 by Alfred Wegener, a geophysicist and meteorologist, continental drift also explained why look-alike animal and plant fossils and similar rock formations are found on different continents. Wegener thought that all of continents were once joined together in an ore continent before breaking up and drifting to their current positions. But geologists soundly denounced Wegener's theory of continental drift after he published the details in a 1915 book called The Origin of Continents and Oceans. Part of the opposition was because Wegener didn't have a good model to explain how the continents move apart. Though most of Wegener's observations about fossils and rocks were correct, he was outlandishly wrong on a couple of key points. For instance, Wegener thought that continents may have flowed through the ocean crust like icebreakers smashing through ice.
Earthquake can originate from sudden motion along a fault, from volcanic eruption, bomb blasts, landslides, or anything else that suddenly releases energy on or in the earth. Some faults are slippery, and the two blocks on either side just slide by each other passively without producing major earthquakes. In other cases, however, the blocks sticks together and deform until they reach a certain point at which they suddenly slap, releasing energy in an earthquake event. An earthquake originates in one place, then spread in all directions along the fault plane. The focus is the point in the earth where the earthquake energy is first released, and is the area on one side of a fault that actually moves relative to the rocks on the other side of the fault plane. The epicenter is the point of the Earth's surface that lies vertically above the focus. Most earthquakes occur along tectonic plate boundaries, along cracks in the lithosphere called faults, or along the mid-oceanic ridges. But the majority of the seismic energy released in the world is from the earthquakes occurring along the plate boundaries, particularly around the Pacific Rim, or the so-called Ring of Fire. Now that we're done with the basics, let's jump right onto the topic of weathering and erosion.
Weathering. Weathering describes the breaking down or dissolving of rocks and minerals on the surface of the earth. Water, ice, acids, salts, plants, animals, and changes in temperature are all agents of weathering. Once a rock has been broken down, a process called erosion transports the bits of rock and mineral away. No rock on Earth is hard enough to resist the forces of weathering and erosion. Together, these processes carved landmarks such as the Grand Canyon in the U.S. state of Arizona. This massive canyon is 446 kilometers or 277 miles long, as much as 29 kilometers or 18 miles wide, and 1,600 meters or 1 mile deep. Weathering and erosion constantly change the rocky landscape of Earth. Weathering wears away exposed surfaces over time. The length of exposure often contributes to how vulnerable a rock is to weathering. Rocks such as lavas that are quickly buried beneath other rocks are less vulnerable to weathering and erosion than rocks that are exposed to agents such as wind and water. As it smooths rough, sharp rock surfaces, weathering is often to the first step in the production of soils. A single type of weathered rock often produces infertile soil, while weathered materials from a collection of rocks is richer in mineral diversity and contributes to more fertile soil. Soil types associated with a mixture of weathered rock includes glacial and alluvial sediments. Weathering is often divided into the processes of mechanical weathering and chemical weathering. Biological weathering, in which living or once living organisms contribute to weathering, can be a part of both processes. Mechanical weathering is process of rocks crumbling due to rain, wind, or other atmospheric conditions, and it is called physical weathering. Chemical weathering is the process changes the composition of rocks, often transforming them when water interacts with minerals to create various chemical reactions.
As future civil engineers, we need to know the importance of geology in our field.
The importance of geology in civil engineering. Geology provides detailed report that contains type of rocks, which is known as petrology, types of formations, which can be found in geological structures, and physical properties of Earth, which is also known as geophysics, which are fundamental in civil engineering projects. The applied knowledge of geology helps in locating the feasible site for natural hazard and environmental protection management of different infrastructures. Geology provides systematic knowledge of construction materials and their occurrence, formation, durability, strength, hardness, and uses. A detailed and accurate knowledge inventory of geology is an essential part of a hazard analysis and prevention. The stability of civil engineering structure is considerably increased through the background of geological features like faults, joints, bedding plates, folding solution channels, and etc. are properly located and suitably treated.